Well, we're continuing on our manufacturing day today, all day long, with different manufacturers and organizations. So thank you again for joining us. If you weren't here earlier, I am Beth Gallick. I'm the Executive Director of the Bay Area Manufacturers Association, and we are an industry-focused membership organization serving manufacturing here in Tampa Bay. So we work with manufacturers in all 3 counties in the Tampa Bay area, Pasco, Hillsborough, and Pinellas counties. And our mission is to advance Tampa Bay manufacturers through workforce development, networking, education, advocacy, and technology. And we are part of the Florida Makes Network, and Florida Makes is the manufacturing extension partner for the state of Florida. As you're joining us today, please get those questions together. Introduce yourself if you're a new class that's come on. Please introduce yourself in the chat box. Tell us the name of your school, your current class, what grade level your students are attending today's session, and how many students you have. If you are a community partner or a BAMA member, let us know who you're with, what company you're with, and what your interest is in manufacturing. We'd love to hear from you and hear who's with us today. But now we're headed to our next organization, and I would like to introduce from AMRoC, Terry, and welcome today. They're a fascinating organization located in the University Mall, and Terry's going to tell us a little bit more about what they do and how you can get involved with AMRoC. So welcome, Terry. Thank you for joining us.
Hello, everybody. Can you hear me okay, first of all?
Absolutely. You sound great.
Fantastic. So I'm Terry Willingham, as Beth said. I'm the Executive Director for the Foundation for Community-Driven Innovation, which is a nonprofit that runs AMRoC Fab Lab. AMRoC stands for the Advanced Manufacturing and Robotics Center. And a Fab Lab is a chartered organization, kind of like a makerspace, but with a capacity building focus and entrepreneurship and small business focus. So what we do here, and you'll see a little bit of it, we'll take you around and give you a little short tour. What the people with me are Brandy Jackson, who is the program director for the foundation. And behind me is Vicki Gonzalez, and she's the operations manager here in the Fab Lab. So what we're standing in right now is actually a little room where we do laser cutting. And Vicki will get something going there. So we've got some laser cut items here. So you've been hearing from big manufacturers. I think some of you have been on for the full tour, but there's an in-between step for manufacturing, and small companies, like Pete said, a lot of manufacturers are smaller. If you scale it down even more, when people are developing products and coming up with design ideas, they need to prototype, right? So maybe some of you have robotics programs in your school. We actually run our first robotics competition program from here and a First Tech Challenge program. And so one of the things that you need to do when you're building things is make small samples. And it can be really expensive, especially if you're a small company and you're trying to design a product. You need to have a place where you can do 1 or 2 samples, or work out the kinks on a design before you spend a lot of money to mass produce the product. So we sort of fill that stopgap measure, and also function as an educational platform for youth and adults who are trying to learn some of these skills. So I'll let Vicki tell you a little bit about what she's doing over here.
Okay.
Well, I was going to say,
we can bring it over. I'll bring it over so we don't come unplugged. Okay, here we go.
So right now we're actually working on awards for.
Oh, I knew it was going to do that. Okay, just talk.
For the FRC off-season competition that we'll be having this weekend over at Brooks de Barlow. So we're laser etching acrylic awards that will end up looking like this with a light up background. But right now they're with the design with the logo of Roboticon for this year, and with different types of awards for the competition.
I'm going to attempt to move it again. If we get shut off, we'll turn you back on closer to the laser cutter. Here we go. All right, it's being good now.
It's starting, but
yeah. So you want to tell them about the laser cutter itself, or?
So you can kind of see the design itself is over here in our software. We've transferred it over, and right now we're etching on acrylic, so it's a little hard to
they can see it. Yeah.
But
there you go.
Basically, this machine is it's technically considered a hobby machine. It is 24 inches by 48 inches of cutting space, and basically it's 100 watts, and it can cut plastic, wood, fabric, paper, cardboard, a bunch of different materials. You can do a lot of different prototyping in many different fabrics, many different tools and materials.
Like earrings.
And earrings.
Like earrings, I make a lot of my own earrings. We make posters. We do a lot of swag gifts for people. We do a lot of awards for schools, all different types of products.
And I like to point out too, one thing you hopefully notice here is that we're all women, right? Beth is a woman. There's a place for manufacturing, for women in manufacturing. And not all of the manufacturing that you see is going to be big industrial stuff. Like she said, some of it's jewelry, right? Some of it's other things, some of it's awards. All of these things are manufactured. They have to be made. So we do both subtractive. I think you may have heard some of these words, subtractive manufacturing and additive manufacturing here. I can't see the questions, Beth. So if there are any questions in there, if you can just, throw them our way, but, we'll come back. We're going to do a little tour and we'll come back and check this out in a minute. So we'll want to do a quick swing around the Fab Lab and tell us, okay. I'm going to follow Brandy around.
So hi, everybody. I'm Brandy Jackson. I used to be a teacher at Hillsborough County. I taught robotics courses at Eisenhower Middle School, but I also run a small company that works with AMRoC Fab Lab to develop hands-on training for companies across the United States and for the U.S. Navy. And so one of the things we want to be able to show you is how it looks when you get the ability to do real hands-on learning in manufacturing. A lot of times in our classes, we're doing a lot where we are studying the process of it, but you need a place to physically go and do it. That's what AMRoC is for. So if we look behind here, you can see in our pictures, we run programs where people can come in and learn how to do electronics, learn how to solder, learn how to take things apart and build some skills. And then we have a full-on machine lab. This is actually everybody's pretty much favorite place to be, because when you come in here, you have a full workspace. When I was in middle school and high school, we still had these in every single high school. But nowadays, that's not always so true. And you need a place to go and learn how to do hands-on learning safely. So this year, we're actually launching a program with USF, a program in mechatronics, learning how to use robotics to do manufacturing. We're going to run that program right here. When we're finished with our first pilot, it's going to be something we can bring to our younger students as well. So what we want you to be able to see, when you learn how to use these machines, when you learn how to use a drill press, a chop saw, a table saw, hand drills, all those things, how to use them safely, being OSHA certified so you can safely use these equipment. Now you can go and use computer navigated programs. The program that Vicki was showing you is a computer navigated laser cutter. It's cutting with light. But we also have really cool programs that can do cutting through metal. So you could get a laser that is strong enough to go through metal. We don't have one of those. They're super expensive. But what we do have is 2 CNC routers for cutting metal. Now, why would anyone need to cut metal? That's because here in AMRoC, we have a community-based robotics program. That means if a school system doesn't have a robotics program and you're like, man, I really wish that I could do some hands-on robotics, you can come here. You can do it here. In fact, we're getting ready for our biggest event of the whole year, and that's Roboticon. It is every weekend in October, and our community members go to high school all over, and what they do is build pretty giant robots. You guys want to see?
Is there a question there? We can't quite hear you.
So if you put it in the chat, Beth will read it out. We can loudly hear it. But this is one of our team's actual robots. They build this themselves. We have career mentors that come in, teach them how to use the machines, and then the kids do it all themselves. It's not a part you go buy at the store. You make it yourself. Real manufacturing. These robots do some super cool, awesome things. This weekend, they're going to be at Brooks to Barlow and competing with robotics teams around the state. And then the rest of this month, on Saturdays in October, there will be manufacturing and robotics programs at University Mall. So what Vicki's showing right now is their advanced articulated arm system. This robotics arm can pick something up from very high, bring it down, sit it down into a shipping center, because the reality is the human body can't do all of this. It's not necessarily great for our joints. And if we can build robots and do it, we can make working in manufacturing safer.
Anybody have any questions?
We do have some questions. So are most of the robots created at your facility, created with parts manufactured in the lab?
So
gonna
one of
put
the
it down
things
over
we
here.
do is there is a really great robot. Why don't we put it up here so it like
There we go.
doesn't go from underneath our chins?
There we go.
We're women, I'd prefer that.
There we go.
So there's really great robotics companies where you can buy some parts, like your motor systems, you're gonna buy those parts. Your sensor, you're gonna buy those parts, but everything else that's on the robot, they manufacture themselves. They go into CAD software. You can do it in Onshape, you can do it in Tinkercad, you can do it in a lot of different programs. Doesn't matter where you do it, because as long as that technology is accessible for you, that's all we care about.
I'll also add that sometimes the reason you have to use particular items is because it is a competition and there are legal components, like any competition or any kind of requirement, right? So sometimes there are things you're required to use from certain manufacturers or certain suppliers. For the purposes of the high school robotics program, there's safety issues, there's reliability issues, there's fairness issues, so everybody stays within a certain budget to create their robots. So this team actually swapped out. They had a tank drive system, which drives like a tank, so you're going to move forward or backwards on either side to maneuver the robot. They decided over the summer that they wanted to switch to a swerve drive, which is more, it pivots quickly, it moves quickly, you can slide back and forth with it. So they started swapping that out with these modules down here, and that's a really complicated system to put in, but it's an industrial application, right? And so they can learn these things on the robot, get real-time feedback on the things they've done, and then be able to apply these things at a higher level as you move on into college and other careers.
So I wanted to talk about, sometimes I know for like my son and for a lot of our friends in high school, sometimes you don't have the time to give a full-on commitment to a giant robotic season like this one, where they travel to different states to do competitions. But we also have a program that is available K to grade. When we talk about K to grade, what we mean is people from any age. One of our youngest groups that have ever come through were 5 and 6 year olds for this program. And our oldest group is 72 and 73.
Yeah.
And that program is combat robotics. How many of you have ever seen a little show called BattleBots? Right? That show's awesome. Well, we actually do combat robotics right here. We have groups that meet together and they learn how to build a robot from scratch. You can buy parts from wherever you want, or you can use our laser cutters, our 3D printers, our CNC routers, once you're trained to start building your own robots. The idea is that robotics and manufacturing shouldn't be limited to where you go to school. It should be only limited by how much you are willing to learn. And the reality is we can all learn it. I'm a trained English teacher. That's what I went to school for. And about 9 years ago, I bought my first 3D printer and I haven't looked back since. This summer, we did an awesome program, Miss Vicki and I. Slide over here, Vicki. So Vicki helped us work with the U.S. Naval Department and the Office of Naval Research and STEM. And we invented an underwater robotics competition. Vicki was in charge of building all of the maps and building all of the imagery and the text that we would be using for the workbooks. And we just got back because we launched this program after piloting it here at AMRoC during the summer. We just launched it in Rhode Island, Massachusetts, and Connecticut. So a lot of the stuff we do during the summer is really pushing innovation. So if you're looking for a cool thing to do in the summer, you need to get some volunteer hours, you want to get like any type of like micro certification to show that you're building skills beyond what's just available in your school or in your community, stop on by because we've got it and we're doing some cool fun stuff.
And how can they apply or find out more information? Is there a website they can go to?
Yes, we have a website. Yep,
Yeah.
I'll hop in.
Yes.
So, AMRoCTampaBay.com is the website, and I think some of you saw the video. We'll make sure we can actually put it in here in chat. Actually, somebody can type it in there. for me.
Okay.
So
I'll type it in there.
there we go. So AMRoCTampaBay.com. We're at University Mall, which is literally down the road from University of South Florida. We're at the west end of the mall. The mall looks a little bit apocalyptic because there's a lot of construction going on here as they're redeveloping it. But we have 8,000 square feet here. I don't know how much time we have, Beth, so I don't want to take up more time than necessary, but there's also there's a whole classroom space up front. There's 3D printing lab. We actually have sewing as well, because sewing is part of manufacturing, right? You have to, sewing, fashion industry is big. There's a lot of other things that sewing is used for. And so like the students actually sew often, I can't get them over here. They're bumpers for their robots, right? So they have to have their numbers sewn on. So they make their bumpers. There's sewing required on those. It's upside down, but yeah. So we use a lot of different things. Manufacturing is many things, right? And
what are the fees?
there are some fees involved for being part of the robotics team, like a student fee that helps with t-shirts and snacks and things. But our programs aren't any more than $200 a year, a school year, for the robotics programs. The other things are on individual basis. We have some class fees for different programs and camps and things like that. But mostly we're really grateful we can do the things we do because we have great community partners like the Bay Area Manufacturers Association. And we work with Softworks and a lot of other different companies, Sensible Micro, that make a lot of these things possible. We just working now with Symbotic, which is new in the area. And so we have these partners who understand that in order to keep running their companies, and that most companies, like Pete was saying, have a small number of staff and crew, we need to train people to be able to do this in the future. It's a good career. It's an interesting career. We're always doing something different here. And so it's fantastic. So we're here to build that workforce through these hands-on programs that are fun to do and give you skills for life.
You were talking about training for the CNC. What does that training look like? You know, how long would it take and how would a student get involved?
So we're working on that with the robotics instructors. Just brought them in and are going to help us develop what that class looks like. But with our laser cutter, we know that for our laser cutter programs, you've got to come in and learn how to use the software. You're looking at 2 or 3 days minimum of doing some basic software. It's a couple hours. And then you're going to learn how to cut a basic project on the machine, do that safely, learn how to guide the systems, and then you're basically checked out on what you need to do. Which is really a great opportunity. It's a very basic process for it. And we believe strongly in you learn a lot from your failure. So we don't limit you when you make mistakes.
And all our students who are on the robotics teams actually learn how to use the CNC machines as part of their robotics program. Yeah. So they learn the software, they build the parts that are machined through the CNC here are the gripper on there, which I'm probably not aimed at it. The gripper and the side things, almost all the pieces on the arm were CNC'd. And again, it's not a huge part, but it just creating those parts shows mastery of the equipment.
That makes sense. And to answer your question, our next manufacturer is coming on at 12:30. So we have as much time as you need. Students are kind of coming and going. So whenever you need to leave, just let me know, but we'll continue as long as we have questions and as long as you're willing to.
We can take a walk through the front if you want.
Let's do it.
Okay. A little bit brighter out there too.
So when you walk into AMRoC University Mall, you barely even see this place and people are shocked it's here. But let's go see what's in the rest of the spot.
Then we'll circle back and see how the laser cut pieces are doing.
So in our lab, we actually have a lot of different working spaces. So we're going to turn and pivot this way so you can see the whole thing. When we go from this all the way to the front, we've got a little under about 4,000 square feet of mobile space. That means everything that's in here can change and adjust. We often have field trips come in. We put together something special for the school to be able to build, be able to do, to be able to challenge themselves. We've got different options we can do. So if we turn over here to the corner, kind of walk in here for a second. This is one of our spaces. Yep. This is our mechatronics lab. Our mechatronics lab is really designed so that you can explore all the types of 3D printers. Often people are like, oh, I have a 3D printer. I know how it works. You know, you know how your 3D printer works. Because every machine is just a little bit different. And people often think that because a robot is inexpensive, it means it's terrible. Actually not true. There's some really great, very accessible 3D printers. So we bring them in, like this little guy, he's $2.99. It's one of the best 3D printers I've ever seen. I've installed 70 of these around the United States.
That thing worked nonstop during the state fair, 10 days nonstop.
We accidentally dropped it
And
off
we
his
dropped
truck
it.
and it still worked. It was great. Like literally dropped it on the ground and it still worked, which is awesome. We've got, I'm gonna turn around some more.
Okay.
We
Oh,
help
perfect.
test. A lot of stuff that we do is we really help other companies test their own prototypes. So when this group, Sendoa, first brought out their 3D printers, they asked, hey, can we put one into your space? And can you have students learn how to use it? And absolutely. We've got the Sendoa, we've got Dremels, and then we have over here in the corner, this is my personal favorite space. I love soldering. It is probably my favorite skill that everyone should learn how to do. And teachers, if you don't know how to solder and you want to learn, give us a call, come on in, I'll teach you how to solder. I'll give you some soldering irons to take back to your school to use it, just bring them back. We've got quite a bit of equipment that's been donated by the MITRE organization, the MITRE Electrical Engineers, that really bring in some stuff to let kids explore how to do soldering and how to build electronics. And one of our biggest and brightest stars out of AMRoC actually came right out of here at high school. She graduated, didn't follow that typical path. She had a child. She went off to Cape Cod Community College. She spent 2 years there. She got her AA in electrical engineering, worked for a little bit. Then she went to USF, got her BA in electrical engineering or BS in electrical engineering, worked for a little bit. She started her own business that she actually helped pilot here. And now she runs it all over places called Bits for Bots. She just joined USF in their MoMA business school, because the reality is you're always going to be learning as long as you have resources that will support you and you have things you want to know. Let's go a little bit further out here. Our main 3D printing center is right here up front. These are our, I like to call them our big baby bears and our mama bears, because they're giant 3D printers. They're almost always running. You can come in, you can say, hey, I've got a 3D printer that I want to bring in. Okay, great question. Do you have community partners that you work with to provide networking opportunities for students that want to get a job in an adjoining work field? Yes. So first of all, we work with Career Workforce Center. So during this, like usually happens in February, they send out some paperwork and say, hey, anybody want a summer job? Fill out that paperwork. We're one of the options, and you can come and work here. And all summer long, we've got all different career leaders coming in and working here. We also, the mentorship programs are designed that way. In fact, we have quite a few engineering companies that say they'll hire someone out of AMRoC over anyone else, because they know kids that come out of the AMRoC program really have the skills, because it's all hands-on.
And we also work with a number of other companies that when students are looking for internships, we work individually with them. Not a whole lot of companies do the high school internships, but a few do now. And I can certainly connect some. I think Honeywell does, and we started working with Honeywell. They're doing some high school internships. So definitely reach out to us if you can't find an internship. We're happy to help you connect with some.
The next question is, do you work with your students to teach them specific skills that are needed for industry certifications, or do you just focus with skills for robots? We don't just do robots. Reality is that robots are an introduction to lots of career fields. In fact, we're getting away from calling it robotics at all. Because if you try to go to college and apply for robotics engineering, it's really hard to find that program because it doesn't exist. It's actually called mechatronics, mechanical engineering, electrical engineering, computer systems, and control systems. It's all four. And there's certifications across all the different areas. People don't know it, but the state of Florida is the #1 place in the entire United States for mechatronics programs. We have 14 organizations that do mechatronics certifications. And here at AMRoC, we're going to be the very first organization to have a micro certification in mechatronics. What is a micro certification? What does that even mean? There's some really technical words. They're called blockchain. And what blockchain is who you are online, right? We call it a digital footprint. Well, it used to be everything that said you had work skill was whatever you put on a resume. People can lie about resumes. So blockchain allows you to save all of your certifications, but most certifications are test-based at the young age. And then as they move higher and higher, they get skills. For me, I don't want to take a test if I haven't been able to do hands-on first. So that's what we do here. With USF, we're launching a program called micro-credentialing, and you'll be able to come in, do hands-on projects, get certifications. There'll be micro-certifications, and those micro-certifications will track to those industry certifications you're interested in, because there's a lot. You might come in, start learning something and think you really wanted to be an electrical engineer, and then find out, you know what? You're pretty bang hot in coding, and you would be excellent as a security analyst, a cybersecurity coder. And those guys make major bucks because everything we make in the United States also has to be protected in the United States. So we're going to focus on how to get you those skills. So let's walk a little bit further into the shop so you can see some other cool things we can do. Ask questions, it's popping up in the chat, and we'll be happy to help you out. So this is probably the most favorite room, even though it's a little bit messy,
Because we roll everything out.
because everything rolls out. So this is our sewing station. Our sewing station has some of the best equipment and has the very best teacher. Her name is Miss Liz, and she comes in on Tuesdays and Wednesdays and teaches sewing. But not just sewing. She teaches you like the history of how things were made, not in a boring way. You're not sitting in history class, like actually doing things constantly. But all of it that lives in this room, everything at AMRoC is on wheels. And everything's pretty highly technical.
Yeah, it's a sewing machine, but it's
It's a pretty technical one. And
a little
so
CNC.
it's a little CNC that works with thread instead of blades. So everything rolled out here into the main space. People come in and hang out. Back in the olden days, we used to call them a sewing circle, where people would come in and learn and hang out and chat together. And one of the things people really say all the time is when they come in here, they just feel like they belong. And that's good, because that's why we work so hard to keep it this way. So all of you are in school, right? You probably have a school patch or your school initials, have shirt that has your school's name on it. So one way to do that is to do an embroidery system. So this is our CNC embroidery system. You can help us learn how to do it, because a lot of times people say they want to learn something, so we buy the equipment and then we have to learn together because we can't know everything. But this particular program, this particular machine, you can actually design your own logos and get them embroidered on a design, kind of like.
Yep, on my shirt there. I think Miss Beth has one on hers too. She's got
Yeah,
some
I think
embroidery on there.
she's wearing
Yeah.
something logo right
Yeah.
there. Everybody needs a quiet place to think sometimes,
Or
right?
design.
Or design. You just need a quiet place to be, a quiet place to learn. So this is one of our offices. This is what we call the think tank. This is a place where entrepreneurs can come in and have a meeting, be in here, do some quiet work they need to do, and then come out and learn with the different people that are here. We work on K to gray. We are literally working with organizations, to build programs. You're right. CNC is definitely a subtractive manufacturing. I was saying the way the computer navigated sewer. So it's a computer navigated anything. So it's similar skills because you still design it.
Numeric, yeah.
You just it just drops something down instead of. So I guess it would actually be an additive machine.
I think it is.
So we make a lot of opportunities. Someone asked a few minutes ago, Aviva, I'm totally throwing you on the spot. So everybody say hi, this is Aviva. So Aviva came to us through USF. She was 19 turning 20, or were you already 20? You were 20. She came over here to volunteer from USF, and we put her right to work. And since she's worked with us, she's worked with quite a few different industries, about 7. She's even traveled with us to Boston to do some work there on one of our organizations, which was pretty cool.
But what's interesting is Aviva does media and marketing, right? And so when you look at the different roles in companies, she also now can use a bunch of the equipment in here,
but she can do media and marketing for different manufacturers. So we actually work with another partner who specifically does media for a cybersecurity company, right? But she understands that company. In order to be able to do some of these things, even if you just have sort of peripheral interest in some of these things, when you're doing these different roles, which all these companies need, it's really important to understand how manufacturing works or how a company works, so that you can do their sales and their marketing and all the things that are involved with that as well. So there's a lot of different roles within companies, and you can literally exercise all of them right here.
Yep, that's really our goal. We just started launching, we're going over the lending library.
Okay. This way.
Personal favorite place. What else, Steve? You're good. The lending library / Steve's office. Steve is our CFO. He makes sure that we pay all the
Steve.
bills.
Somebody has to pay the bills.
That's right.
Yep.
Someone has to pay the bills, so we get to keep the lights on. That's important. Speaking of paying the bills and keeping the lights on and keeping things safe, the U.S. government is really working on bringing manufacturing and microelectronics and chip design back to the United States. The only way they're going to do that is if people like you get those degrees. So what we've done is we've started building out resources for our teachers. This is our lending library. Now I'm talking to you, teacher. So we're building it piece by piece, step by step. Inside this space is a ton of electronics and manufacturing resources, curriculum, so that you can learn how to do this at a very small scale to teach concepts in your school and bring it back. You can actually come in, train how to do it. We've got a book of resources. You scan it, you do the lesson. Once you've done the lesson, you're checked off, and you can actually check some of our resources and take it back to your schools. We really believe accessibility is very, very important. Am I looking to hire additional staff? If I can get more funding, absolutely, because I need a nap. For sure. We work with Career Workforce to bring in temporary staff throughout the year. We typically have 1 or 2 at a time. They work with us for 8 to 14 weeks, depending. And the goal is that during that time, they're going to use all of our different manufacturing tools. They're going to learn a little bit about marketing, a little bit about video production, a little bit about event management. And then when they're done, we can actually help them figure out what job they're interested in and then get them to the right place. So we're always looking for companies that are looking for people and are wanting someone that's been a vetted, hands-on, experientially trained student, because that's what we do here. Everything's hands-on. No tests. Some tests, but not many.
The test is, does your robot work? Does your product work? Is it, is it marketable? Do you understand your marketing? Can you mass produce your items at an affordable rate so you can make some money off of them?
So before I was showing you the FRC, that's our big robot. That's a pretty gigantic robot. He's very expensive to build. But one of the little bit more accessible robots is the FTC robot. I call him the first tiny robot. He's not really tiny.
It actually stands for First Tech Challenge, but Tiny Robot works too.
It just helps me remember which one. So this is a robot. You can see it on the ground. It's orange. They are working on this robot. This robot's going to be doing all kinds of stuff. But one of the things he does is he launches airplanes, which seems crazy, right? Why are you building a robot that can launch airplanes? Interestingly enough, in Kenya, a company, a very, very small company, has completely redesigned the way they do blood delivery. In Kenya, they have low electrical systems. They're not always turned on. So, because they, it's just low infrastructure. And so they built a solar farm. Connected to that solar farm, they put in a blood bank. Connected to the blood bank, they put in a drone system. And now they use gliders that literally someone gets on a cell phone and says, hey, I need a bag of AB negative. And they're like, cool. And they go grab an AB negative out of the refrigerator, I guess. I don't know. And they put in a little thing and they attach it to the drone and they put the drone coordinates in it and they pull it back and they shoot it into the air using a slingshot rubber band system. So the same thing these kids are going to do with this robot that is throwing paper airplanes used to save lives all around the world. In fact, during the Puerto Rican hurricane, that was one of the things people tested. If we can't get in to a location, how can we get things to them? How can we deliver them quickly? So manufacturing comes in all different ways. Over here, this is our more stationary computer lab, although everything is on rollers. So we definitely move things in and out. In fact, last week we had the Sensory Sci-Fest and we moved every single thing, this whole entire workshop somewhere else. We almost gave Miss Terry a heart attack, but it was really fun and a really great opportunity to show that science is for everyone, including kids on the sensory spectrum. Then this is our favorite program, and this program is currently still free. So if you're interested, you should check it out. This is our combat drone lead.
There you go. Well, the adults use it as combat. The kids use it as a strategic game.
I'm
Yeah.
competitive.
Competitive. Yeah, it's actually an aerial drone competition program from the Robotics and Education Competition Foundation. It does get kind of combative when they run into each other.
Right.
But we actually use co-drone EDUs. One of the things Brandy was talking about was the importance of having products made either in the US or with US friendly countries, because that's just a requirement now. And so this program was slow to expand because the drones used to be made in China. They've switched over to a new drone company called Co-Drone EDU, which, by the way, teachers, is an absolutely fabulous drone system for schools. It's affordable. It's made in South Korea. And it's full of sensors. You can program it. It'll swarm. You can do all sorts of different things with it. But every year, the students, like with all of our other game-based programs, get a game to play, and they have to, in this case, learn how to pilot their drone through it, also program it to do certain things, because there's also an autonomous skills challenge where you actually have to program your drone to fly through the field in a certain pattern without any human intervention. So really cool stuff.
Yep. And then the thing that I think a lot of people first find AMRoC for, watch out for those people, is one of our biggest partners is we actually help people launch their own small businesses. And so we run a program called Equity and Entrepreneurship here. And
Is Miss Michelle in there? Where's Miss Michelle?
I don't know where she went.
Okay.
So this space next to us is the Strike Esports Center. Everybody loves little video games. And I know our parents often say we're not learning anything when we're playing video games. We would say you're wrong. There is a huge industry and how we're going to be using AR and VR and your skills in robotics to actually work in manufacturing and in construction. And so it's really interesting that we're able to have this location right here inside of AMRoC where people can go, they can take classes where they learn how to code, do designing, and then they can, play competitive video games. I found her, she's hiding in the side.
Oh, Miss Michelle's hiding over there. She may not want to be on the camera.
Can we show you? Oh, she's coming around.
Oh,
She's
good.
coming over here.
Oh, that's Miss Michelle. So she's a co-owner of Strike Esports. I don't have my glasses on, so I think you're in there. She's I'm showing the and she is also the board chair for Foundation for Community Driven Innovation, which is a nonprofit that runs our space. And her daughter went through the First Tech Challenge program, the little robots we just saw, and she is a software engineer at Lockheed Martin. So these programs scale. The skills you learn in them take you to different places than you might ordinarily have expected. I think she's way over there. You probably can't hear her. So I'll probably screw up your story, but her daughter's interest was initially tennis, which is a great interest. And then she learned about the robotics program, got involved in that, and ended up taking a career path towards software development. And I think now she's even morphing to a different project management. Yeah, so now she's moving into project management. So these programs lead to a lot of opportunities and a future that you may not have considered. And what I always like to tell students is don't ever feel like you've arrived, like you accomplished something, you're done, right? If we're doing it right, we're never done. We're always learning, we're always growing, we're always pivoting. We're always finding new ways to use our skills to make a good living and to have a good life.
I promise that when you graduate high school and you're like, this is what I'm going to be when I grow up, it's what you're going to be when you grow up for right now. Because the reality is you pivot and you change. And AMRoC is really about giving you those opportunities. We're going to take you outside. So when you walk in the mall,
Can we ask another question real quick about the video games? So talking about, different careers in, video games are very exciting, I'm sure, to lots of kids. So we have programmers, but what other opportunities are there if kids are really interested in video games? Are there opportunities for, say, writers or, other opportunities? What is the scope and the variety of different opportunities?
Yeah, graphic arts, coding, game development, there are a lot. My daughter, after going through the program here, she went to Florida Poly, and they have a lot of different things, as I'm sure USF does as well. A lot of different programs for gaming. It's an entire major at Florida Poly. Yeah.
For the military, you get trained as a white hat hacker. Most video game people that are really into video games, we learn how to break them pretty quick, right? What are the shortcuts? How do you get in there? How do you get faster? That skill of being able to get around a game and win faster is actually a skill that the military looks for. So they actually go and look for gamers and hire them as white hat hackers. They also hire them as drone pilots, actual combat drone pilots. They use them, people that are really good in the AR, with the big headset thing that makes me nauseous when I try to do it. They actually use those to have people work with like robotics exoskeletons to do like physical labor jobs. In fact, we had a really cool video a couple weeks ago. There was a guy, he was driving a forklift and a bulldozer and a cherry picker all at the exact same time. How could one person drive 3 machines? Because they were all robots. And he was sitting in a really sweet plush gaming chair. He had 6 screens up with all of his construction jobs. And literally people would say, hey, I need the forklift to come and move this thing for him. And that's what he would do. He would literally drive the forklift using the joystick, over there, pick whatever he needed, drop it off. And so be like, hey, we need the bulldozer over here. He would do his job at the bulldozer. And those skills come from being really great in the virtual reality.
Medical field too.
Yeah.
What's the contact info for Strike?
It is strike.gg.
Right there. We'll also send that. You can even type it in there.
If you could type that into the chat, that would be amazing.
All right.
Strike with a Y. And we're on all the
Oh.
social medias, so
Just do Strike with.
please find us, follow us.
All right. And so hopefully that gives you a good look at a variety of different things that you can do with manufacturing, and that
We'll
all
show how
the-
to get to our front door.
yeah, we're going to show you how to get to our front door. So there's the Strike. And then Strike is actually right at the front. Everybody likes to walk past the door and go over to ask us how to get in the Strike. You just go to the first door.
Okay, good to know.
All right. And here we are. We are in a mall. Literally a mall. Behind us is View Studios, which is a high-end production studio. And we're at the far end of the mall, the west end, and there's AMRoC. So
Where's the best place to park when you get to the mall?
if you go to our website, there's actually a little video that shows you how to park. It's actually the northwest end of the mall. So you actually come around off, if you're coming off of Fowler, you just come to the back of the mall. You can park there and come in the entrance in the back. Right?
Okay,
That way.
wonderful. And so you have a very exciting event coming up this weekend. If students are interested in stopping in, are they able to do that? And where would they go?
So if you're going to be going to see the first robotics competition event, that's the big high school level robotics that you saw in the back in the shop where we're headed now. You're going to go to roboticon.net for the full schedule. And that event, the first weekend's event, is being held at Brooks to Bardlow High School. The address is on there. It is just west of 275 on Central Avenue. It's just maybe 3 miles from AMRoC. Oh, here's our finished laser cut items. We were actually,
I'm gonna peel them now, but we cut awards and I'll show you now.
yep, and Vicky was actually making the awards for Roboticon. So we actually can manufacture our own parts for the different things that we're doing. We do a lot of our own trophies and a lot of our own thank you gifts and things like that. And so she can see she cut it with the paper on it that's naturally on the acrylic, and you peel it off. It smells like nail
you got your
polish.
nails
It's like you just did nails.
We have the
Yep.
etching here, and then you'll get to see it light up now.
And then
Oh,
when
I
you
love
talk
it.
about different skills, Vicky is an artist by trade. She's an illustrator. And so she can create her own artwork, and she knows how to use the equipment to laser cut it or to 3D print it or to cut it by hand and do a number of different things for assembly.
And
So-
that's something I always like to emphasize on, because a lot of times, I mean, I felt as a child when people are like, robotics, electronics, it's this one category. And it's really not. You can do so many different fields, so many different things. And again, being an artist by trade, I also am a fabricator. So I would do like prop design. So knowing electronics and knowing those aspects helped me on the art side of creating amazing props for theater, for theme parks, for things like that, or creating my own products like invitations or doing graphic design for these companies so they have a nicer, clean look. And it all overlaps. You can all have different types of backgrounds and things involved. So, yeah.
And I was just curious to know what different types of materials you use in the 3D printer.
Miss Brandy's waving goodbye. She's got to hop on another call.
Thank you.
What was the question again?
What different types of materials do you use in the 3D printer?
Oh, so for the 3D printer, we mainly just use PLA. There's also ABS, but for prototyping, PLA is usually the main way to go for 3D printing. For laser cutting, that's where you can get more of acrylic, wood, fabric, papers, cardboard, different types of certain plastics. It depends. You want to test out. Certain things are toxic with flame, so you don't want to use vinyl. But yeah,
There's a lot of varieties now. There's wood type filaments and all that different things.
You can cut masonite on there. You can cut chipboard on there. A lot of architects always laser cut their 3D models, so they're doing a type of chipboard for their models all the time. Yeah.
Anything else?
All right. Is there anything else that you'd like to talk to the students about, or even just advice for students on, I know that one of the things is
Hand's going to sleep.
getting involved in AMRoC, coming down to the facility, getting involved. But is there any other advice you would give to students as they're starting to prepare for their careers?
I would say do a lot of things. Explore a lot of things. Try everything, right? Don't limit yourself to say, well, I don't like math, so I'm not going to do that. Or, or I don't understand how 3D printers work, so I don't want to, learn it all, right? Try everything, and you'll find out as you move along. I'm a writer by trade. I got into this because my son liked robotics, and I like to understand the things that my kids are into. My other daughter is an embalmer in a funeral home in Dunedin. Our third daughter works as a media specialist in Oregon and does environmental studies stuff. So, and all of them cross-trained in their childhoods on everything, right? They followed each other, the robotics events or musical recitals or everything else. The more well-rounded you are, the happier you can be, and the more opportunities you have as you move through life to pivot, to change your mind. It's okay to change your mind. It's okay to come back to things later on. Did you have anything?
Yeah, no, and I was going to say that exactly what Terry is saying, having that experience, and even if it's not a career path or choice, it's always helpful for daily life and just having experiences. Oh, now you know how to fix something in your home. It doesn't have to be your career, but you can explore it, and then you can decide whether or not you want to explore this as a career path.
And be curious. Be curious. I mean, it's one of the, I think one of the biggest killers to a good future is being too good to be curious. Check things out. If you don't understand how something works, ask somebody. If you're looking at something and you want to understand it better, take the time to understand it better. So I think the curiosity part is critical.
And one of the huge things about Fab Labs as a whole is that shared community and working together with others. So you don't have to know everything, and you usually don't. And you'll always team up with someone else. So be open to learning, being open to knowing that you don't have to know everything, but you guys can figure it out together. Or someone else will come along and bring up a whole new idea, a whole new way of training and experiences that you never had. So
real quick, I brought Mr. Wellingham over. He's my other half. He's our co-founder, and he is an electrical engineer by trade. He used to work for the Harris Corporation, which did a lot of work on the International Space Station.
Yes.
And so he started as an engineer. He can tell you where he went.
Yeah. So engineering is, of course, an incredibly important career path for students that are interested in technology and so forth. And what I always teach the students that we work with, impress upon them, is that when many of them that do go through the engineering curriculum, whether it be here at USF or any other university or college, that is an important foundation. It is just their foundation. They get to learn all the details of the mathematics involved, all the nitty-gritty things that you must know just as the foundation. You really start learning after you graduate and you get your first job.
It looks like we may have lost them. Does anyone have any?
I don't see them, or
Yeah, I think we lost them, so may have lost internet connection. So we'll see if we can get them back. Daniele, thank you for staying with us today. While you're on, I don't know if all of our schools that are on know about FLATE and what you do. Would you want to give another little brief update of the resources that you can provide?
yes, of course. Let me turn my camera on. Good afternoon, everyone. No, yes, afternoon. I'm Danielle Orozco, CTE manager for the Florida Advanced Technology Education Center. We focus, and here's my colleague, Teresa Potter. I will talk about me a little bit, and then Teresa will continue to introduce herself. We focus in manufacturing in Florida. We are the Center of Excellence, and we're National Science Center Foundation, regional center, like I mentioned, here in manufacturing. Representing Florida, we are one of the top organizations, not profits, focusing outreach, curriculum, and professional development. And we are here to serve you. Teresa, would you like to say something?
We just wanted to say, sorry, our battery died.
Oh,
we noticed that.
I figured we lost you. We're letting FLATE just say a brief couple words, and then we'll be right back with you. If you still have a few more minutes, Terry.
If you want us, we'll be here.
Yep.
Yep, we'll be right back to you because we want to hear what you have to say and finish up with your thoughts. Teresa, you're on mute.
Thank you. I'll just wrap up by saying that I put our Made in Florida website in the chat. And if you click on the careers section or the manufacturing month section, you'll get a lot of information about careers in manufacturing and other resources on how to reach out to connect with manufacturers, like through Beth at BAMA. And I believe AMRoC's on there as well. We have a lot of resources from across the state and in this area. We'll turn it back over to AMRoC.
Thank you, ladies.
You're muted. There we go. Now we're not muted.
Welcome back.
You're right. Happy to be back.
No matter how advanced you get, you still need power.
Yeah. So let's see, trying to fill out the thread that I was on there about students being involved in engineering curriculums. And as I was saying, I impress upon them that no matter what field of engineering that they study, whether it be electrical, mechanical, civil, anything, manufacturing, what have you, again, it's a foundation. It's a very important foundation from which they will begin to really learn after they graduate. In my particular case, as Terry mentioned, it was electrical engineering. Went right into, immediately had a job with Harris Corporation on the east coast of Florida, working on space programs, aerospace. I actually have a system that I worked on that's currently in the space station. But then I was, after about 15 years or so, I like to say that I was hijacked away from them by a company on the west coast of Florida that was willing to pay me almost double. Like, okay, well, you know, we have a new family. It's time to move on, so on. So would I impress upon the kids too, that when they go into their career, do the best you can, learn what you can, but don't feel like you are tied to one particular company. Often you'll find that as you as your career progresses, there'll be zigzags, right? It's rarely a straight line in a single company. So if you're going to zigzag, take advantage of that, and try to make have an increase in your salary or what have you for each of the zag. It can happen, and it's important to do that.
And then he ended up with a Fab Lab, so.
Oh, well, yeah, if you retire, it's like, well, you're not really retired. You have a lot of energy still, and there's things you want to do. So Terry and I co-founded the Foundation for Community-Driven Innovation.
Are there some questions there? I was just looking to see. Can't see.
Don't know.
Yeah, I don't see anything right now. Okay,
Okay.
just wanted to check.
Yeah.
So that's our story.
Yep.
We're sticking to it. Did anybody have any other
Thank
questions?
you
or
so
anything?
much. What are some of your, as being in a career in manufacturing, what's some of the most interesting things that you've manufactured, or some interesting things that you've done in your career, or, what you've learned throughout your career?
Yeah, well, again, interesting. It's kind of like what I tell the kids about. You really start learning after you graduate. So the first position that I was put into was called reliability and maintainability. They don't teach that in college, right? What the heck is that? So as it turns out, when you're working for the government and they're putting something in space, they want it to last a certain amount of time, right? That might be 10 years, or this satellite has to last 15 years, or what have you. How in the heck do you prove that? How are you going to say that's really going to work that long? So you have to go through and analyze every component that's in it, and how is it connected? Is it in parallel? Is it in series? Do you have a single point of failure, or what have you? So that was a very interesting learning experience. So I did that part of the position for about 3 years, and then moved over into systems engineering, which is like on the other side of the spectrum. It's where you get to really design what the requirements are going to be for a system, and then how it's going to be tested and so on. Very interesting. So,
Any particular products or anything you made that was really interesting?
well, it's interesting when you're working for a large company like that. Sometimes it's a very complex product, and you're only working on a very small part of the system, a subsystem, they call it. So yeah, there's been subsystems that I've worked on where there's been a larger satellite. Interesting project that we were on actually did the information systems in airports. Okay, that was interesting. I didn't realize, we went through and interviewed all the people that are involved in the back end of the airport, how many different systems there were in there, and how disconnected they all are, which is why sometimes we have issues when we're traveling.
The airports come to us
Yeah.
because the systems didn't work sometimes.
Exactly. So I think they're connected a little better now than they were back then, but still, yeah, it's pretty much any project that you work on, it can be very interesting.
You got to see some of them launch into space.
Oh
Right?
yeah.
Yeah.
Oh yeah.
And
Absolutely.
actually, when he was working on the space station, it wasn't called the International Space Station. It was called
No.
Space Station Alpha.
Oh yeah, Alpha, and then it turned into Space Station Freedom.
Freedom. Yeah.
Yeah.
Yeah, that's got to be fascinating. Is that, when you started your career, what was your vision for your career, and how has it changed from what you initially thought?
Yes, right. So I was going through electrical engineering curriculum, right, in school. So my thoughts always were, okay, I'm going to be involved in the electrical part of everything, the schematics and the design of the electrical systems and so on. However, once graduated, I did very little electrical engineering, other than when I was evaluating the reliability and maintainability part. It was very important to know how the electrical components interacted with each other and what they did and so on, and why a certain part would heat up too much, or why it wouldn't, so.
Wasn't it White what he originally thought electrical engineering?
No,
Yeah.
not at all. Yeah. So, moving on from that part into the system engineering, I really enjoyed the system engineering part. That's where you got to talk to essentially the customer, who was the government. Or when I moved into the commercial aspect, after I left Harris, you're speaking to the customer and you're understanding what their needs are, and then you're determining what are the kind of requirements that I need to articulate, that now the developer can understand what the requirement is. And then they can build, and then you can test it according to those requirements. So engineering is a whole lot broader than what you learn in school.
Yes, there's a whole world out there. But thank you so much for sharing your experience with us and all the students today. Thank you, Terry, for the tour of AMRoC. I wish you success on Roboticon this weekend.
Out every weekend. October 14th, we got the elementary school kids. The 21st, I believe we're doing combat robotics. And then the 28th, we're doing the VEX robotics competition. So every Saturday we'll have a different thing here in the mall. If you want to just check it out and see what kinds of things you're interested in. We have a lot of the mentors or engineers who work with the students or are involved in the industry in some way. Good opportunity to come out and talk to them. We have a career expo going on at Brooks to Bardlow as well. And so you can come out and meet some of the folks there.
Okay, wonderful. Thank you so much. Have a great month, a manufacturing month, and thank you for joining us.
Everybody.
Thank you.
Thank you.